Hello everyone, I am Tishitha from 3rd ECE. In this presentation, I would like to explain you about discrete correlation. Before moving on to discrete correlation, let's know about discrete convolution. Discrete convolution is a mathematical operation which is used to express the relation between input and output with the help of impulse response of a linear time invariant system. In the given equation, x of n is the input and y of n is the output. The convolution can be calculated as y of n equals to x of n convolution h of n, where h of n is the impulse response. On combining two signals, we get a third signal y of n. This equation can also be written as sigma m equals to minus infinite to infinite x of n convolution h of n minus m. A mathematical operation that closely resembles this discrete convolution is discrete correlation. This is the measure of degree of similarity between two signals. This correlation can be performed either with one signal or between two different signals. If it is performed with one signal, it is known as autocorrelation. If it is performed between two different signals, then it is cross correlation. General formula is Rxy of L equals to sigma n equals to minus infinite to infinite x of n into y of n minus L, where L takes values 0, plus or minus 1, plus or minus 2 and so on. As said earlier, there are two types of correlation, cross correlation and autocorrelation. Cross correlation is the measure of similarity or coherence between one signal x of n and the time delayed version of the other signal y of n minus L. Cross correlation of two signals x of n and y of n is given as Rxy of L equals to sigma n equals to minus infinite to infinite x of n into y of n minus L. Cross correlation can also be found via graphical techniques. Here, the L is called as time shift parameter and the subscripts xy indicates the direction in which one sequence is shifted relative to the other. Shifting x of n to the left by L units and shifting y of n to the right by L units is relatively the same. If L is positive, then it is said to be positive shift. If L is negative, then it is said to be negative shift. The procedure of cross correlation involves sliding the time shifted version of one signal y of n minus L over the signal x of n. In the previous slides, we have seen Rxy of L, where x of n is remained the same and y of n is shifted through L units. Now, if we reverse the order Ryx of L, then y of n is kept constant and x of n is shifted through L units. Equation 3 here, as shown, can also be written as sigma n equal to minus infinite to infinite y of n plus L into x of n, which means shifting x of n through L units relative to y of n is same as shifting y of n through L units relative to x of n. By comparing equation 1 and 2 in the previous slides and 3 and 4 in the present slide, we obtain Rxy of L equals to Ryx of minus L. It means that putting L equals to minus L in either of the equations 3 and 4, we obtain equations 1 and 2, that is Rxy of L. Let us take an example on cross correlation. Let x of n equals to 0, 0, 2, minus 1 and so on, where x of 0 is equals to 1. And y of n equals to 0, 0, 1, minus 1, so on, y of 0 is equals to 4. To find out the cross correlation between two signals x of n and y of n, we use this formula. Sigma n equal to minus infinite to infinite x of n into y of n minus n. Firstly, L takes values from minus 7 to 6 because beyond that, even if we multiply x of n and y of n, we obtain 0. It's not necessary to take beyond minus 7 and 6. So firstly, when we put L equals to 0, the cross correlation between x and y at L equals to 0 becomes multiplication between the signals x of n and y of n. There is no shift taken place in both of the signals. So the product signal after multiplying this x of n and y of n is 0, 0, 2, 1 and so on. where we find out that x of 0 is given 4. This product can be obtained like 0 into 0, 0, 0 into 0, 0, 2 into 1, 2, minus 1 into minus 1, 1, 3 into 2, 6, and this is that sequence. After summing all these values, we get the value 7. So at L equals to 0, the cross correlation value is 7. Let us put all other values of L. When L equals to 1, the equation becomes x of n into y of n minus 1, where n takes values from minus infinite to infinite. In the previous case, x of n and y of n were same. I mean, they were not shifted, they were kept constant. In this situation, x of n has remained constant and y of n is shifted by 1 unit. In this, when y of 0 is equals to 4, now y of 0 has become minus 2 after shifting 1 unit towards right side. For example, let's say if this is 1, at n equal to 1 the value is 1, at n equal to 2 the value is 1. After shifting by 1 unit, then it becomes at n equal to 2 the value is 1, and at n equal to 3 the value is 1. At n equal to 1 there is no value. This is the procedure taking place here. So y of n minus 1 is 0, 0, 1, minus 1, 2, minus 2 and so on, where y of 0 is minus 2. It has changed. There is a change from y of n and y of n minus 1. Now the product sequence x of n into y of n minus 1 is found as 0, 0, 0, minus 1 and so on. After computing the sum of this product sequence, we obtain the cross correlation of x of n and y of n at the value L equals to 1 as 13. Similarly, computing cross correlation for different values of L, we obtain minus 18, 16, minus 3 and so on. Also putting values L less than or equals to 0, we obtain all these values. Now, the overall cross correlation sequence of x of n and y of n is the combination of the sequences when L less than 0 and when L greater than 0 and when L equals to 0. This is the sequence. We can find that the highest value obtained is 36. What does this 36 means? It means that this 36 value is obtained when L is kept 4. That means by putting L equals to minus 4, we got the cross correlation value as 36. It means that at L equals to minus 4, the signals x of n and y of n are at most similar. So the maximum value at cross correlation indicates that the signals are almost similar at that value. Let us dive into another type of correlation, which is autocorrelation. It is actually a measure of similarity or coherence between a signal and its time delayed version. The time delayed version being x of n minus L and the signal being x of n. So putting y of n equal to x of n in the cross correlation equation gives autocorrelation equation. Physically, signal autocorrelation indicates that how the signal energy is distributed within the signal, where the signal energy is maximum, where the signal energy is minimum, where it is in between minimum or maximum. So in this types of signal, the signal is correlated with itself. This procedure involves sliding the time shifted version, which is x of n minus L, upon x of n at every interval. We shift the given signal by one sample. Now we overlap and then we perform multiplication and then we add from sigma n equal to minus infinite to infinite. Let us find out autocorrelation using MATLAB. In the code written here, CLC means that clearing command window, and closes all the figure whose ever handles are present earlier. Clear all means that clearing all the variables which we have created earlier in the workspace. Since it is autocorrelation, only one of the signals is required, either x or y. So I am taking x here. X label means that labeling the x-axis. So it's represented as n, and y label labeling the y-axis. Stem of x means that it plots the discrete sequence. As in continuous signals we use plot x, in discrete sequences we use stem of x. In the title given as input signal 1. So to find out the autocorrelation, we use the keyword xcorr, XCORR, x comma x. So it plots the correlation sequence. Similarly, x label, y label, and stem of z, and the title. Let us see the output of the code which we have written. At n equal to 1, the amplitude is 1. At n equal to 2, the amplitude is 2. At n equal to 3, it is 3. At n equal to 4, it is 4. At n equal to 5, it is 5. Similarly, they have also represented the y of n signal, and the autocorrelated signal comes out to be at n equal to 1, the value is somewhere around 5, I guess. At n equal to 2, somewhere around 18, and so on. We can see that at n equal to 5, the autocorrelated signal amplitude is very high. It means that at that value, the signals are at most similar. There is no shift between either of the signals. Let us see the next example on cross correlation. Similarly, which we have seen in the autocorrelation CLC close all, clear all. And the extra signal which comes into play is y of n here, which I have taken 4, 1, 5, 2, 6. So it means at n equal to 1, the amplitude is 4, at n equal to 2, the amplitude is 1, and so on. And as explained all the terms before, the same thing happens here. Let us see the output of the code which we have written. Similar to the previous code, at n equals to 1, it is 5, etc. N equals to 2, somewhere 19. And at n equals to 5, it has reached very peak. It means that the signals look approximately or very much similar at that n value. And that's all about cross correlation and autocorrelation, which are a part of the discrete correlation. Thank you, and I hope you've got a good understanding about discrete correlation.